welcome back to the shop. Today I want to share with you some technical information about what a CNC is able to do. Usually we use it for machining operation and sometimes for engraving operation. And when you make such thing like a CNC, you touch also to the electronic files, and you need some time to make some PCB. So that I want to show you is the possibility that a CNC is able to do with PCB, and especially as the accuracy of the machine is very high, you can make some very small parts and some very small engraving. So in this video I will show you all the process of making some engraving on a PCB. And it's very useful because sometimes you have some prototype to make only for 2 or 3 LED, or to change some wires, some voltage and things like that. So it could be very helpful, and if you have the CNC machine, it's very easy to make it. In the other hand, if you have a lot of same parts to do, CNC is also very well adapted for this kind of operation. So we'll see the complete workflow for making some engraving operation on a CNC, even if you have a big machine. Mine is something like 6 foot long and is able to make some very small parts and some very small engraving dips. And I will show you with a small project I have on the end, and from the design of a PCB up to the CNC engraving. So the first step you have to do, you have to make a PCB design, and for this operation we need to go back on my computer to show you how it works. And you will see there is some tips how to make it easy and with free software only. So see you on the computer for seeing the workflow of the process. So back on my PC, for the first thing you need when you want to make a PCB engraving is to find a good software, and especially a CAD, electronic software. That I would recommend is Eagle. You have the name here, and there is mainly 3 reasons for that. The first one, if you are making just some hobby application, Eagle is free, and Eagle is able to run on any kind of platform, Windows, Linux, Mac, so you can use anyway. The second thing, as it is a well-known soft, you can find thousands of tutorials on the way to use it, and some tips about that, so the learning curve will be very short. And the third reason for using Eagle is the fact that they have a huge library for components. So it will be more easy for you to find what you need, and if you don't find some electronic components or whatever, you can download on a web so many libraries, so it's very useful for that. So that's why I use Eagle when I need to make some prototyping in electronics. I always make simple things, because my knowledge are more based on the mechanical things that on the electronic side. So that you can see on the screen is a very small board. The blue color are the traces that join the component, and you can see various components on this board. So you have some screw connectors, you have some resistors, you have some LED and so on, but we are more interested by the trace by itself, and also the holes and the position of the holes on the thing. So that's I will not explain how to use Eagle, and you will find many tutorials about that, but I will explain how to come from this PCB, this board, to your CAM software. And when you will have the it's on the CAM software, it's very easy then to make some CNC machining. So the first thing we need to do about this board is to hide the thing we do not need. So Eagle is working with layers like many CAD software, and the layers are here. So what I would recommend for hiding the component, because we don't need a component for the engraving operation, you display the layers, you click on None, you click on Apply, and everything disappears, and you just take the thing you need. So the thing you need first is the bottom. So you click on Apply, so you can see the trace. You need the pads, so you click on Apply, and you see also the pads. You need a dimension, I guess, so you click on Apply, dimension, Apply. So, and as you can see, we have the outline of the board, we have the trace, we have the holes. It's enough to make a step forward to going for the CAM soft. So you click on OK, then you go to File, Export, and you choose Image. And here is the tips there. You give a name. So let's give this name to this file. The resolution, you have to use 2400 dpi. Unfortunately, Eagle is only working with pixels. So when you change the resolution, the image size will change, and you need to take care about that, and I will show you why in a few minutes. But the thing that's worked best for me is 2400 dpi, and use also monochrome, so we don't need those kind of color. It will be more easier to to make the workflow after. So then you click on OK to export the image. So I already did that, so I'll say yes, and that's all from the Eagle side. Then you need to take another free software, and the name of it is Inkscape. Inkscape is also a free software working on many different platforms, and it's very great software for designing and using of kind of image. So the first thing you have to do, you click on File, Open. You take the previous file that you export from Eagle, and you say Open. He asks you if you want to incorporate or link the file. It's best to say to click on Incorporate, and then you click on OK. Then you have the file and the trace we already have on Eagle, but the concern at this step is the fact it's a bitmap file, and we cannot work with bitmap file on a CAM software. So that we are going to do with this software Inkscape. We are going to vectorize this image, and Inkscape is very powerful for that, and it's very easy. So the first thing you have to do, you select the entire image, then you go to Path, Vectorize Path. The best thing is use the second option in this menu box, and the value you type 0.950. Then you can click on Update, and even if you do not have a very decent look on the trace, don't worry, it will work very nice. Then you click on OK. So calculation was made on the first image, and what you can see, in fact we have two images here. So you select the previous one on the left corner, you dilate it with del, and what is remain on your screen is only the vectorized image. And now the big thing is that you can go easily to the CAM software with File. You click on Save As. Then you choose the DXF R12, and then you click on Save. And you let the nominal option like that, and you can click on OK, validate. And with this with this type of thing, we come from bitmap file, and we vectorize it, and we go from a DXF, and a DXF is usable by all the CAM software. But I want to show you that there is a mistake somewhere. And if I take one CAM software, so I use 3 or 4 different ones on my machine. But if I take a very simple one like CAD 3D, it's a commercial one, and if I open the file, so delete their original trace, you can see here the CAM software give me the dimension of my DXF file, and the original file. So if we go back to the Eagle file, and I compare, the dimension of this board, that should be the real size. It's the size we need for the component. You can see that the length and the height are different when we arrive here. So the difference is not so big, but the difference is big enough that you cannot insert your component inside. And I spent a lot of time trying to figure out why it worked like that, and it's only because when you export the bitmap file, we use some DPI. DPI are in pixel, and we lost some accuracy. So here it is, the tips for that. When you go to the file, export image, and use the resolution of 2400 dpi, you cannot change it easily. So that you have to do. You have to manipulate the size of the bitmap file or the trace on Inkscape. So it's very easy, and I will show you how to do that. So you remember, it's the trace we obtain after the vectorizing of the bitmap. So that you do, you select your vectorized file, then you go on object, and something you have an option that is transform. Then you have dimension, and if you click this option, the X and Y will move in the same time with the same quantity. So you preserve the square in X and Y. And I calculated that from my software, the difference is around 5%. And that I did. I enter the dimension, the percentage that will give the final dimension correctly on the backend software. And that I calculate is this number, so 69. So there is something like around 5% between the DPI and the dimension when using this method. So then you click on apply. So the size had been reduced a little bit. Then you go to so you can close this window. You go to close, save as. You take the same file. You save the file. You replace the file. Validate with the basic option. And if we go back to the CAM software, so I will do a time. So laser original trace open. No. You can see here that I'm very close to the final dimension. So it's 40.3, and so this dimension, let's say on the X dimension, and on the eagle we are 40.31. So we have 40.309. So we are very close. And if you look at the other dimension, is 17.78 for the 8, and we have 17.75, 77.5. So the thing to know, the tips about that, is the fact for any reason between the original Eagle file and the DXF, there is something like 5%, and precisely the number I give you, it's 95.169. And if you do like that, now you can use those traces as regular DXF file. You can make some engraving operation, and I will show you how to obtain the best quality on PCB on the machine. So here it is from the PC side. I hope it's not too complicated, and especially for obtaining the proper dimension between Eagle and the DXF file. But I guess it could help you a lot between this electronic file and the CAM software. So now we are going on a CNC machine. We need to make some special setup because the engraving operation is very accurate, and we need to make some dedicated setup, and we will go back on the machine to see how to create that. So see you later.